Hello everyone, how's it going? Today we'll be discussing the various applications of Markov chain. So to start off, first up we have PageRank. Have you ever heard of this before? Because this is something that is some I learned very recently. I was not aware of it in the past. So let me explain to you what PageRank is. PageRank is when you search something up on Google or Bing or any other search engine like Yahoo, you have links that pop up, don't you? Various hyperlink list that pops up like this, and then you have the page number, and you can scroll down and go through different pages and find the link that you're looking for. Now, Google or Bing, either way, they determine the relevancy of the link and then they push it to the top. So the link with the most relevant to your searches will be at the top, whereas the link at the bottom will be least relevant. And as you go past each page, the information becomes less relevant to the keywords that you searched up. So Google determines this based on the keyword that, that are in the search. And in a visual way, we can represent this using a graph. So suppose you have a graph like this. And it's not the typical graph like the x and the y axis or xyz, but this is a data structure concept known as graphs for anyone who has taken it. But don't worry about that right now. You just have to focus on this aspect. So you make your search, you have the search, then it executes, then you have a list of links, so the list of hyperlinks that you see, and then you can click on those various links. 1, 2, all the way down to 10 or more. Just for the sake of argument, we'll keep it to 10. And then each links have their own separate nodes here that you could scroll to. So link 1 would have the most weight. So let's go with the number 30 being the largest, whereas this would have the link 10 would have the least weight, so let's say 6. And this could have probably like 25. Link 2, link 10. And the higher the weight of the link, the higher it gets pushed up. So the higher the weight, the higher it'll be on the hierarchy. So the higher the weight, the more relevant. That is essentially what PageRank is. And next time you do make a search on Google, just know that the first link that appears will be the most relevant to your searches. Okay, that takes care of PageRank. Let's move on to the next one. You have stock market prediction. For anyone who has invested in stocks, I'm sure you have heard the terms such as bull, bear, and stagnant. Let's define these terminologies for those who haven't. So let me draw this diagram. I'll get back to it to explain what this means. Okay, so bull is when the market is booming. So everyone is buying stocks, profits are going up, you're getting your dividend payments. So when the market booms, it's called the bull phase. So profit. Bear is when the market is down. So suppose everyone is selling their stocks, prices are dropping, you're losing money if you had stocks in certain companies. So that's called bear. So you're losing money. And stagnant, which is quite rare by the way, means there's no change at all. Now by the Markov chain application, it is said that if the market is at bull phase right now, then it is highly likely that the next week will also be bull and the following will also be bull. Whereas if the market is bear right now, it's highly likely that the next week will also be bear and the week forward to that will also be bear. Whereas it's not as likely for the market to go from bull to no change or the market to go from bull to bear within 1 week. So the probability of going from one state to another is very low. So the probability of going from one state to another, there's a terminology for it. It's called the transition matrix. And that's essentially the definition of that, the probability of going from one state to another. And therefore, this loop, as you can see, this probability is higher in comparison to such as going from here to here or going from here to here. And that's basically how Markov chain is used to predict the stock market, which is quite volatile and highly unpredictable. Okay, third way, we have word prediction. So suppose for the sake of relevancy, you search up a famous holiday such as Christmas on Google. Just Christmas, you haven't typed in anything else. As you know, Google fill in suggestions for you, such as movies, trees, cards, etc. So, suppose previously you have searched up Christmas movies to watch, and Google will save that on your computer or mobile, and the movies will search up at the top. Actually, no, let's go with the better example. Suppose you have searched up Christmas trees that you want to buy for shopping. So, as you can see right now, it's at the second place, right? But since you previously searched up trees, it'll be pushed to the top. So, that will be the first thing that comes up, Christmas trees. And it'll have this clock icon that will say Christmas trees. And this will not appear. So why is that? Okay, so Google determines this based on your previous searches. So for the ease of convenience, any information you have searched up previously that gets pushed to the top rather than the suggestions that appear. So this has a higher priority than the suggestions that Google does give you. Your previous searches have a higher priority than the suggestions that appear on Google because there's a likelihood that you might search it up again. And that's a concept, another fundamental concept associated with Markov chain that is implemented by Google in their algorithms. Okay, fourth, we have speech recognition. So nowadays we have AI such as Siri, made by Apple, of course, and Cortana, such a made by Microsoft. So these AIs are conditioned to execute one command at a time. So if you give it multiple commands, suppose we use the visual here as a diagram for commands. So suppose you give it a chain of commands. Command 2, command 3. What do you think will happen? Do you think the AI will execute all three commands one after another? No, wrong. The previous two commands get cancelled out. The AI only executes the latest command it was given. Why is that? Because, well, rationally, if you're giving multiple commands, the AI won't know what to do, which one to execute first. So for that, it was built in such a way that it ignores the previous commands and only focuses on the present command. This concept is also a Markov chain property known as memorylessness, meaning the previous events, aside from the one that is relevant, is ignored. And that narrows out a lot of information and makes it easier for us to make predictions or analysis in various fields and departments, making them more accurate. That is how AI is typically used to perform tasks and to ensure that multiple commands do not execute simultaneously because it could lead to problems or malfunctions. Because if you tell the computer shut down and then tell it to restart, that will that will not work because they're two complementary commands. So the computer will restart, but it won't shut down, as you stated previously. Okay, I hope this video helped you gain a better understanding of applications that are commonly used by Markov chain. And they are very subtle implementations, so you may not have noticed until I have made this video. So I hope you enjoyed this video. Please leave a like and subscribe. I'll be posting more in the future. Thank you, and goodbye.